We're back at it, and we're going to talk to you guys about chaining. So we started in the first segment with pacing as a quick, easy way to get an approximation on a distance. So the next step towards being more accurate is a chain. And all a chain is a longer tape measure, really. And these chains come in a couple different materials. I'm holding a steel chain. This is what you're going to see a surveying crew come out to the job with. We're not going to see what kind of tape used.
A lot of times they make longer tapes like 100 foot in like a nylon material, and we'll see those sold at a lot of box stores.
Right.
That's because they're selling them to non-professionals. The reason we would not use a nylon tape is because we can stretch the tape, right? We can, over time, that tape could stretch and we're not as accurate as we need to be.
Right.
If we're gonna take the time to get the tape measure off of our belt or out of our tool pouch or pull the chain out of our gang box, we might as well be accurate with what we're doing. And a steel tape is more accurate than the nylon tape.
These tapes are a little bit different than what we use in the lab, what you might use when you're framing a house or something. These tapes come to us in a little different dimensioning. On a regular tape measure, we're using 1/16 of an inch typically as our smallest increment of measurement and the foot as our largest. With a surveying chain, what we're getting is we're getting a tape that is designated, each foot is designated into tenths of a foot.
So I see a 1, 2, 3, 4. That's not 1 inch, 2 inch, 3 inches?
No, that's a tenth, 2 tenths, 3 tenths.
So that way, as we climb the tape and we see 9 tenths of a foot, it goes from 9 to 1 foot. It's in tenths, so we don't go 9, 10, 11, 12. So that's very important to remember. This is engineering. This is not just a regular English standard dimension system.
So whereas on a standard tape measure, a foot is 12 equal inch increments.
Right.
So really a tenth is approximately an inch and an eighth, approximately.
Sure. So if we're using steel, we said that's better than nylon. We can just go out and start measuring, and we got to keep in mind that it's a tenth of a foot. Is there any other ways we can make a mistake with the chain?
I'm glad you brought that up. Each make of tape, who the manufacturer is, will have different ends, these loops at the end of the tape. Sometimes that represents a tenth of an inch, so that if you were to butt this tape into something, you would have to do it at the end of the loop, right here. As you can see, this tape is not like that. The tape actually starts at 0 and goes. So when we butt in, we don't want to pull past this. We need to have that where our mark is, or what we're coming off of. And it's crucial, because if you don't get it right, all of a sudden you're an inch and an eighth off of where you need to be.
Right. So you need to know where 0 is.
You have to know where 0 is.
End of the loop, beginning of the loop, and sometimes on some chains, it's 2 clicks in on the chain itself. So understanding where 0 is, understanding that we're working with an engineering scale, those are the 2 main ways to make a mistake.
Right. So if you guys have watched the video we put up on chaining, you've got the series of steps, best practices. And I think that we want to go through what the steps are in chaining so you guys can observe it being done, and then we're going to go over some of the best practices.
And best practices meaning care of your tools,
care of equipment,
body positioning, taking into account, if we're really going to be highly accurate, taking into account tension on the chain,
yes,
temperature of the day that we're chaining, because if it's cold out, what's going to happen to our chain?
It's going to shrink.
It's
right?
steel.
Yep.
And the steel will expand and contract based on if it's a hot sunny day, 95 degrees, or if it's 25 degrees and cold and cloudy. We have to take all of those best practices into consideration if we want to be as accurate as we can be.
Okay. Let's show them a little bit of the equipment we're going to be using. Mark's going to grab a few different items that a surveying crew would have with them when they're out chaining, if they're running a traverse or whatever they're doing. Mark, you want to tell them what you got in your hands?
Sure. So the first tool is a tensioning device, a measurement device. So we can hook the loop here, or our hook onto our loop, and we can pull tension, and you'll see that it'll measure pounds of pressure. And based on the temperature that day and the standards, we can hold, and I can say I need a certain amount reading of pounds of pressure, and make sure that we hold that chain under tension at my pounds of pressure reading, and make sure that we're following our best practices. This makes it easy to hold on my end. But remember, Scott's holding a piece of steel in his hands. Might be unsafe if we're trying to put that under pressure, but we have another gadget that helps us at his end of the chain.
It's like a pair of scissors missing the blades of the scissor. So what we can do is we can slide this cam system over the tape, and you can see that with this, it's kind of oblong here. And once I bring the loops together, now I've got pressure on the tape, and now I can pull without running the risk of my finger sliding down the chain and cutting myself.
And we talk about good body position. If Scott and I are 150 feet apart and I'm trying to get, say, 12 pounds of pressure, I don't want to be standing like this because I don't have good body posture. My arm is vibrating. It's making it hard for him to hold on to. I want to make sure my feet are anchored. I may have a plumb bob hanging down off, so I'm holding above the point I need. I'm going to keep my arms tight to my body because now I'm stronger like this, and I can hold my position with my feet braced, because we get up to 20, 30 pounds of pressure. I'm wanting to lean forward, so I need to have some backward motion, feet anchored, arms in close to my body, so we can put the proper amount of tension on the chain.
Absolutely. Good point. Okay, so let's grab the surveying pins there. As we're traveling linearly across the site, taking our dimensions, measuring out whatever we're doing, we need to know where we've been once we've done the dimension. So we're always going to use chaining pins, which is just has the candy caning on it, looks like a big candy cane. But what we do with this is we'll stick this in the ground once we've attained our dimension. And we use it as a point of reference as we're traveling away from.
Sometimes we'll use different color ribbon so we can keep track of our points that we've set in the ground, because we may be chaining over great distances and recording in our field book our measurements as we go, and this gives us that visual reference to sight back or sight through one pin to the next pin to make sure that we're on the correct path.
So as we go through and we chain for distance, what we have to be cognizant of is the lay of the land. And what I mean by that is, are we losing elevation away from a point of reference? So if Mark's set up over a point and I'm traveling to, say, chain out 100 feet from that point, if we're losing elevation down the slope of a hill, if we chain down the slope of the hill, what are we doing to our dimension? It's not the same. If I'm going down, I'm traveling down a longer distance. If you think about right triangles, I'd be traveling down the hypotenuse, right? If I'm going down a hill. So when we're chaining, our chain always has to remain level. So if my hill's going down like this, instead my 100-foot dimension needs to come level off of it, and then we need to be able to bob down or plumb bob down to that 100-foot mark. If I just measure down, I'm going to be short, okay? Because, or it depends, but I'm going to have the wrong distance.
So if we had to go a long distance and it was a fairly steep incline or decline or incline, we'd have to break the chain.
Yes.
Right? Because if I run downhill from you, I can't be holding that chaining tool above my head.
Right.
I'm not strong enough. So we'd go down in a series of measurements, and that may be 10 foot at a time, 20 foot at a time, 50 foot at a time,
Right.
where we can still maintain the good body position, still maintain a level chain, and then we just record each segment as we go down until we hit the number that we were looking for.
Absolutely.
And that's called breaking
Breaking the chain. Thank you. Okay, you want to try it? Show them real quick, or is there something else you want to talk about?
I think one other mistake or error that commonly happens, and I'm sure you've done it, I've done it, and I know if we've done it, that means we've made a mistake. A lot of times you'll see a person, because the chain might have gotten a little bit worn, let's say, right near the end. So instead of trying to hold on 0, we might hold at 1 or 2.
Right.
And that can lead to a math error in a heartbeat. So we say, well, I can't cleanly see where 0 is, so I'm going to hold it at 1. Well, if my partner doesn't know that and he's calling out, we're at 100 feet, if I just cut a 1/10 of a foot, we are not at 100 feet. And if that error continues to happen, or if he thinks I'm holding at 1 and I'm actually holding at 2, the error just keeps getting greater and greater and greater the more measurements we link together. So don't cut a number, always read from 0.
Absolutely. Absolutely. That's a great point, because it's something we do, especially if you have a little bit of background in the trades. I don't know many carpenters that don't do that.
Right.
Because we can get a little more exact by cutting an inch and lining up our mark on the inch mark,
Yeah.
right? You know, we can get a lot more accurate than butting in, especially if we've damaged our tape.
Yeah.
But it's never a good practice out here.
And we want to take care of our tools, right? So when the chain or tape gets worn, buy a new one or replace the blade. We can see here, we haven't
Why
done
don't
a good
get
job.
the camera to come in and take a look at the chain so that we can illustrate how not to take care of your equipment.
You see this discoloring here? This is rust. So that tells us that the chain was used in a wet environment. Maybe it was just misting a little bit, or heavy dew on the ground, or had just stopped raining and they laid it down in the grass or the concrete and got it wet. That's going to happen. But we need to dry and oil the chain
Absolutely.
before we store it.
You know, it's pretty cheap to go buy a can of WD-40.
Right. Take care of your tools so they're doing the job they're meant to do.
Absolutely.
Another way we can damage these tools is it has a tendency to go back to its home position, which is in a coil. So if we lay it out on the ground, one, we don't really like laying a lot of tools on the ground because they can get stepped. We can throw a kink in the chain. We can put a loop in the chain by accident. Now, if we would pull against that loop, as we pull tight, the loop can actually kink over and put a crease in our chain.
Crease or snap it.
And then if we crease it, it's no longer accurate. We can't get it to lay flat. We can't pull it correctly. We snap it, we're buying a new one no matter what.
Right.
So we take care of our tools. You know, you don't just throw tools into the gang box with no care. When we get into surveying tools, Scott, the ones we showed now are the basic inexpensive tools. How expensive does some of the robotic GPS-based surveying tools? What are we talking about a price tag?
You know, today, Trimble, $25,000 to $50,000 per unit.
So we don't set up our instruments and then leave the job site and go to lunch. We don't set up our instrument in a haphazard manner where it can fall over. We don't throw the instruments into the back seat of the truck. They're made to go back into their cases to protect them and protect the investment of whoever wrote the check for the $20,000, $30,000, $40,000.
Absolutely, absolutely. If you don't manage that process on your job as superintendent or a project manager, teaching your workforce to respect the tool. Because what happens is Companies don't react real, we have budgets in the office too. We have tool budgets for that's company wide. They don't like to purchase high-end stuff because lack of maintenance.
Right.
We want to lose equipment. We want to phase equipment out because they've come to the end of their useful life.
Right. And if we've paid for that equipment and we've gotten a good useful life on it, the tools and equipment are making us money.
Absolutely.
If we have to replace them too often, we're losing money. And
Right.
since our margins are small, we have to control every penny on the job.
And remember that your workers, it's not their tool. It's the company's tool. So some people don't have as much respect if it isn't theirs. So we have to get them in the mindset that if they take care of that tool's always going to be there to take care of the job.
Right. Good point.